All right, welcome students to today's lesson on this rainy day outside. What we're going to be looking at is trigonometric equations. So to begin with, we're going to start with several categories of these. The real basic ones are the ones that we're going to begin with. And these are ones that mostly you can interpret from the unit circle in reverse. So the idea is, first of all, generally I'll ask you to either solve the equation on an interval like I do here, or for all real numbers, which would mean I'm looking more like for a formula. And this interval tells me on this example that I want the answer to be in degrees. So basically what you do is you always want to kind of start by isolating the trig function by itself, and this one's already isolated, so you can really just interpret this backwards on the unit circle. So really, if you look at this problem, you're going to look on the unit circle. You know the sign is the y value on a unit circle, so let's just identify where the sign takes on a value of 1/2. So one place is at 30 degrees. Notice the other place is at 150 degrees. So the answer to this problem, we would just write the solution set in degrees, 30 degrees, and 150 degrees. Okay, that's it. Okay, that's a real simple basic trig function where you're finding an angle given the sine ratio. Okay, the next one, we'll do the same thing. We will, first of all, we need to isolate the tangent, so I'm going to subtract 1 from both sides. So you would get square root of 3 tangent x equals -1. Then I would want to divide both sides by square root of 3. Okay, so I will have the tangent function isolated now. And what we need to do on this now is we need to look on the unit circle and make the determination where the tangent takes on these values. And remember, a tangent is y over x. Okay, so when you're looking at a tangent, you're looking at a ratio of y over x. So you need to figure out where it would be -1 over root 3. Well, first of all, the tangent takes on negative values in these two quadrants. In quadrants 2 and 4 is where that's negative. So we just need to see where is y over x equal to -1 over square root of 3. Okay, well, if you notice at this angle right here, so if we just look at 150 degrees, one thing that you'll notice on this is the tangent of 150 degrees is y over x, so that would be 1/2 over negative square root of 3 over 2. That would cross out, so that would leave you with -1 over root 3. So that would be one answer to the problem. The other place this is going to happen is going to be in quadrant 4 at 330 degrees, okay? Because notice that if you look at the tangent of 330 degrees, again, it's y over x. So you would have, again, -1 over root 2 all over root 3 over 2. 2's divide out, so you're left with -1 over root 3. So again, that's what we're looking for, is when that value takes on that. So this happens at 2 places. So the answer to this problem would be on the interval, or not the interval, it would just be a solution set 150 degrees and 330 degrees, okay, like that. So that's your answer to your first 2 problems. Those are kind of simple interpretations of the unit circle, okay? So that shouldn't be too problematic. Now the next one, we're going to do the same thing as I scroll down below here, except the interval is in radians now, so you want to make sure that you give radian answers by interpreting the unit circle. So the first one's already done for you. Okay, it's already isolated. Remember, the cosine is the x value on the unit circle. So what you want to do is look at the unit circle, figure out where x is square root of 3 over 2. Okay, there's 2 places where that happens. Those are the 2 places. And again, remember, your the cosine is positive in quadrants 1 and 4. Okay, so the answer to the problem, again, we're going to give this in radians, is going to be pi over 6 and 11 pi over 6. And we write that in a solution set, okay, like that. All right, that's it. That's all there is to it. Okay, next one, of course, we've got to isolate. And this one we're going to subtract 1 from both sides, which you can certainly do in your head. You just move the 1 to the other side. It becomes negative because you're subtracting. Then you can divide both sides by square root of 2. Okay, and then that will get the sign isolated. So we'll have the sine of x equals negative 1 over root 2. And you can figure it out now if you want to, or you can rationalize the denominator, which is what I'm going to do. And you can do that in your head if you want to. So when I do this, I end up getting the sine of x is equal to negative root 2 over 2. Okay, so what I'm going to be looking for is where that happens on the unit circle. Okay, so we have a negative number here. Okay, so the sign is negative in quadrants 3 and quadrants 4. So you just look down in those two quadrants and figure out where is the y value. The other thing you've got to remember is the sign is the y value. Okay, so if you look down below, the sign takes on this value 2 places. Okay, and you're going to give radian answers from 0 to 2 pi. So you're just one lap around the circle. So the answers would be 5 pi over 4 and 7 pi over 4. Okay, once you get everything isolated, then you can interpret and find that angle on the unit circle. Okay, in this case, we want that to be in radians. Okay, all right, so those are two kind of straightforward examples of the real basic trig equations that we're going to solve. Okay, go to the next one. We have cotangent. This is already isolated, so we have the cotangent of x is 1. So what we have to do on this is you got to remember that the definition, the cotangent is the ratio x over y. So what you have to do is you have to look on the unit circle and figure out where x over y would be equal to 1. Okay, so in other words, x and y have to be the same. So you look on the unit circle and figure out where that happens. And the other thing is the cotangent is positive in quadrants 1. Everything's positive in quadrant 1, but also quadrant 3. So if you notice, this would be kind of the key right here. X and y are the same. That happens at pi over 4. The other place happens at 5 pi over 4. Okay, so the idea with that would be the cotangent, and you don't have to write this down necessarily, but the cotangent of pi over 4 would just be root 2 over 2 over itself. So that would be 1. And the same thing would happen at the cotangent of 5 pi over 4. You would just have negative root 2 over 2 over negative root 2 over 2, so that would be 1. So that means the answer to this problem is going to be pi over 4 and 5 pi over 4. Okay, so that's an interpretation again on the unit circle. All right? Okay, any problems so far? Okay, all right. Now you want to get a really good, simple grasp of this level of a problem, because the more advanced problems almost always end up having something to do with what we're doing right now. Okay, it's almost like the last step you do in the more advanced problems. So this one's a little bit different. We're going to isolate the cosine. So you're going to add 4 to both sides. You can do that in your head. You would have cosine squared x equals 4. Okay, what do you need to do next? You need to get rid of the 8, okay, because you want cosine all by itself. That'll divide out. You'll get cosine squared x. That fraction reduces to 1/2. Okay, now what do you generally do? Like if you had the equation x squared equals 4, what do you do? Well, you know that you take the square root of both sides of the equation, and you get a positive and a negative answer. So you're going to do the same thing on this, and it's real important that you're cautious about that plus or minus. So this would give a cosine of x is equal either 1/2 or a cosine of x is equal to negative 1/2. So you got to make sure that you pay attention to both of those things then. Okay? All right, so now what we're going to do is we're going to interpret on the unit circle, and this should be a fairly straightforward interpretation. So you want to recall that the cosine is the x value. All right, so what we do is we just find where this happens. Where is the cosine positive 1/2? Okay, well, the x value turns out to be there, and the other place is there. So the answer to this part of the problem would be pi over 3, and the other part of that problem would be 5 pi over 3, like that. Okay, then we're going to look at where the cosine takes on the value of -1/2. Again, where is the x value on the unit circle -1/2? 2 pi over 3 would be one place. 4 pi over 3 would be the other place. Okay, so we would have 2 pi over 3, and then we would have 4 pi over 3 like that. Okay, now generally what you're going to do is you're just going to write the answer in one interval. It doesn't really matter what order you put this in, so I'm just going to say pi over 3, 2 pi over 3. I'm putting them in order, but that is not really necessary. And then I just write this answer in one interval. Okay, and that would be all the solutions of that problem. Now what I'm going to do on this problem just is I'm going to show you how to check this on your graphing calculator. That's something that's pretty important because you can make connections on this problem graphically. So the first thing we're going to do is, and I'm going to show you a couple of ways to do this. What we're going to do is we're going to put the original, we want to make sure first of all that we're in radian mode because we solved this in radians. So we're going to do that. And when we go to y equals, we want to just put in, you know, the left side of this equation. Okay, this is at least one way to look at this problem. And so what we'll do is we put in 8. Now we have to square the cosine, so you have to go parentheses, cosine x, double up on the parentheses and square. That's how that has to be put in. And then you do -4, okay, like that. So that would be the way that you would want to set up your window on this problem. Okay, I want to just kind of slide this over here as I do this so you can refer to this if you need to. Okay, now the window we're going to do is, okay, you're solving from 0 to 2 pi. So we're going to go x is 0, x max is 2 pi. Okay, then you can scale by whatever you want to. I'm going to scale by pi over 2, which is every 90 degrees. And then for the y, it doesn't really matter. I'm going to start with -10 over 10 and let's just see what the graph looks like. That's probably a reasonable scale. Okay, so that looks like what the graph of that would end up looking like. So I'm going to slide this kind of over here. And then the other thing that I will do for you here, whoops, what in the world happened there? Let me do that again. I want to just slide these over here so you have a record of this if you need to refer back to the OneNote notebook. And the window will be this. All right, now let me show you basically what's going on this problem then. All right, so our solutions to this problem were this. Okay, and I'm just going to label this on the graph. That is supposed to be pi over 3, because that's where this is equal to 0. The y value is equal to 0. Then you'd have 2 pi over 3 there, and that would be 4 pi over 3, and then this would be 5 pi over 3. So what I can do on this, and the reason is because if you look, remember we had the equation, this is equal to 0. Okay, so we're looking at where that function takes on a value of 0. So notice what I can do is I can trace on this real easily. So I can type trace and I can do pi over 3. Okay, whoa, did I do the right thing? I may have put the wrong thing in there. Let me try again. So I'm in radian mode, so let me do that again. Trace pi, whoops, not doing this right for some reason. So let's try again. Pi over 3. What in the world is going on? I hope I put the right graph in. Okay, I'm in radian mode. Hopefully I hope I solved this correctly. I'm in radian mode. One of my answers was pi over 3. Okay, just a second here. Okay, after further review, as the NFL referees would say, I made kind of a stupid mistake. And some of you may have caught that when I was doing this, so I'm going to go back through this. And I could argue that this is one of the benefits of checking on your graphing calculator, which is true. So what I do on this is, let's go back to where I was. I isolated and I had cosine squared x equals a half, and I did something that's really careless. When I do the square root of both sides, I didn't pay attention to the square roots, what I didn't do, and I bet some of you noticed that. So that's cosine x equals plus or minus square root of 1 over 2. So that would actually break down into two parts. You would have cosine x equals, and you can rationalize this denominator like this. You would have square root of 1 is 1. And let me just go ahead and rationalize this right now. So you get square root of 2 over 2, plus or minus. That's what you end up getting. All right, so what you're going to have then is you're going to have square root of 2 over 2 and solve that equation. Then you're going to have cosine of x equals negative square root of 2 over 2. And I can tell on the graphing calculator that these I'm going to get the right answer this time. That's how I figured out what I did wrong. So basically it goes like this. The square root of 2 over 2 for cosine is right here. So that means you're going to have two answers here of you'll have pi over 4 and you'll have 7 pi over 4. So that should be two answers there. And then it takes on this value here at 3 pi over 4 and 5 pi over 4. Okay, so the other two answers are 3 pi over 4 and 5 pi over 4. Okay, so what I'll do is I'll just write the answer of the problem like this. Pi over 4, I'm going to put it in order, 3 pi over 4, 5 pi over 4, and then finally 7 pi over 4. So I interpreted that wrong. I didn't take the square root of 2. All right, that's what I wasn't paying attention to. So my apologies. I do stuff like that sometimes. So anyway, so what I was going to show you on this now is I'll trace these out and you'll see what I'm talking about then. So I'm just going to trace these out. So if I type trace and if I do pi over 4, okay, like that, okay, that verifies it, see. Okay, and then I can do the same thing. I can trace at 3 pi over 4 and so forth. Okay, you can do that for each one of those things and verify that you have the right answer of the problem. Okay, so it's really a nice thing to do on these problems, particularly if you're a little bit in doubt, if you're doubting yourself on whether you got this right or not. Just get your graphing calculator out and check it graphically, and you might catch a mistake just like I did in the last problem when I was solving it. So that'll happen sometimes. Okay, so that's the correct answer to the problem. It's kind of weird when I traced out 7 pi over 4. It didn't give 0, but it gave something real close to 0. So that looks to be right. So again, that's the pi over 4. This is the 3 pi over 4. This is the 5 pi over 4. And then the next one is 7 pi over 4. All right, so that's how that goes. All right. So what I'm going to do, you can pause if you need to kind of get this corrected and think through that problem. I'm going to go ahead and move to the next page. And on the next page, I'm going to have you do some problems out. If you want to check one or two of these on the graphing calculator, you can. Maybe in particular this one with the square on it. Okay, so go ahead and do these two problems. I've got the unit circles up here that you can refer to if you need to. And I'll go ahead and pause and work on them, and I'll let you check in just a minute. Okay, so let's go ahead and check and see if you're on the right track here. Just first of all, start by checking your answers and see if you got these okay. If you're okay and understand this, you can move on. I was also going to show you, while I was working these out, I put these in the graphing calculator. I'm going to show you a picture of how I checked each of these real quickly with the graphing calculator. So this first one is 45,315. And really on that one, all you're doing is already isolated. You're looking on the unit circle where the cosine is square root of 2 over 2. That's these two places, 45 and 315. That's it. Okay, the next one, now this one, I didn't do anything with a cosecant. So the way I would do this is I would isolate first, then I would turn this into a sine. That's what I recommend you do, because remember the sine is the reciprocal of the cosecant, Okay, what you can do is just take the reciprocal of this number. Now you have sine of x equals this. Rationalize, you get this. So ultimately, you just want to change that problem into that. And then there's two places in degrees where the sine is negative root 2 over 2. There's this place, 315, and there's this place, 225. So that's how I would do that. Now what I'm going to do is I'm going to move over here for a second and show you the graphs of these two and just kind of show you what I did on this. I did this a little bit different way. The way I put this in the calculator is I put, since you were solving the equation, you're solving the equation cosine x equals root 2 over 2. Well, what you can do is you can graph out the cosine, and I did this from 0 to 360, and I was in degree mode when I did this. And I just do this. I just graph cosine of x, and I graph square root of 2 over 2. So what you're essentially doing is you're looking for these intersection points. And if you trace at 45, you would see that you would be at that intersection point. And if you trace at 315, you would also be at that intersection point. So you can always graph the left and right side and see where they intersect. Just trace out your solutions and see if it's right. What I did on the next one here is ultimately we were doing the equation cosecant x equals negative root 2. So I just put in 1 over sine because 1 over sine is cosecant, and then I did negative root 2. So I just did this. And what happens is the points of intersection are here and there, and if you trace it 225 and 315, you'll see that the calculator is going to be blinking on those intersection points like there, so visually you can tell you're correct. Okay. Now I'm going to move over to the next two. These were problems you were supposed to put in Radian mode. This one you should have isolated. You would have got tangent is equal to negative 1 over 1. Basically, there's two places. You're looking at the tangent ratio y over x. There's going to be two places this happens. One is 3 pi over 4, because y over x would be negative 1. The other place is 7 pi over 4. Again, the ratio would be negative 1. Now, I wrote down that ratio. You don't necessarily have to do that, because once you get your trig function isolated, and if you can get the answer in your head, you're just going to do that in your head. But that's how I was kind of showing you what I was doing on that problem. Okay, the next one, you should have isolated the sign. So that would be move the 3, divide by 4, square root both sides. You would have square root of 3 over 2 with a plus minus. So you really got to look at solving two equations, interpreting two things on the unit circle. The sine of x is root 3 over 2, which happens here and there at pi over 3 and 2 pi over 3. And then the sine is negative root 3 over 2 down here and down there. That's 5 pi over 3 and 4 pi over 3. So those would be your solutions to your problem. Okay? All right. Now I'm going to move over and I'm going to show you the graphs that I put in real quick, and then you can pause and look back at this in just a minute anytime you want to. So again, on the last two, what I did is we solved the equation. Ultimately, we were solving tangent of x is equal to negative 1. So I just went ahead and did it this way. After I isolated, I did that. Okay, put that in and graph this in Radian mode. And then again, the intersection points were at 3 pi over 4 and 7 pi over 4. Okay, then the last problem, ultimately when we isolated, we were solving the equation sine squared of x equals 3/4. So I just did it this way. I just checked my answer this way. I graphed this in y1. I graphed that in y2. And then I just traced out those intersection points. So there's 4 answers to that problem, and that's where they lie. So you can study that. You can even put those in your calculator if you feel like you would benefit from that, because it is real helpful to check on a graphing calculator or by hand on these problems. Okay, so I'm just kind of go ahead and pause the video right now if you need to look over these. But if you got those well, then you've got the basics down, and that'll kind of start us through. We're going to still work a little bit more on this in the next example then. Okay, so moving down to the next thing. what we're going to do now is we're going to write a formula. So we're going to solve for all real numbers. We're not going to give specific answers. We're going to give all of the answers that are possible. And on a trig equation like these, there's really infinite solutions because the angle can get infinitely big or infinitely small. So what we would do on this problem, on these two problems, we would just do this and interpret it like this. First of all, this is already isolated. So we just look where x is square root of 2 over 2. Okay, so one place is pi over 4. The other place where the cosine is root 2 over 2 is 7 pi over 4. So when we write the answer, we write it like this. Okay, we just say, okay, x is pi over 4, but the period, remember the period of a cosine is 2 pi. So what we say is we say plus 2 pi k, where k is an integer, and that would be a formula for that. Then we say set of x, we do the same thing on the next solution, which is 7 pi over 4, and then we say plus 2 pi k, where k is an integer. Okay, now let me explain what that's really doing on this. Now that's how you write the answer, but I want to show you something on this. If k can be any integer, so for instance, if k was 0, in this first solution, if k was 0, then you would have pi over 4 plus 2 pi times 0, so you would get pi over 4. That would be a solution. If k was 1, then you would get pi over 4 plus 2 pi times 1. All that would do is that would just be, okay, pi over 4 and then another lap around the circle would give you the next solution. If you got a common denominator on this by multiplying by 4 pi over 4 over 4, you would end up getting 5 pi over 4. Okay, and that would be another solution. And what you'll find is, see how these things are going up by 4? Then the next solution, when k is equal to 2, 5 plus 4 would be 9 pi over 4. Okay, then if you went up 4 again, you would get it 13 pi over 4 and so forth. So you're getting infinite solutions. If k was a negative number, like if k was negative 1, then you would just have pi over 4 minus 2 pi. And if you got a common denominator on that, you would have pi minus 8 pi, like that. So you would just be getting negative angles if you did that then. All right, so it would kind of go like this. You would have 1 pi over 4 minus 8 pi over 4, so that would be negative 7 pi over 4. Okay, so these things follow a nice pattern. Okay, you don't have to write all this down. I just want to explain what this formula is doing. So you would have 5 pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4. It's nice to see the little patterns that exist on this. And if you did this, then you would start getting into the negative answers also once you get into the negative integers then. Okay, like that. So what would happen is you would just start getting the negative angles that give solutions and so forth like that. Okay. So what we would end up having essentially is a formula that generates these answers. The same thing would happen with the 7 pi over 4. If k varied as an integer, you would just get more and more and more answers as you do this then. Okay, then that would be kind of the idea there. Okay, so that's what the way you'd write your answer is. You just write your answer like that, and that would end up being a formula for all those answers then. Okay, that's the idea. All right. Okay, always just add the period. That's what's real important, is whatever the period of the trig function is what's going to go there. All right. Okay, let's do one with a tangent. There's a little thing on a tangent you have to pay attention to. So the first thing I'm going to do is isolate. So I have 3 tangent x equals negative square root of 3. I divide by 3. So ultimately I'm looking at the tangent of x is equal to negative root 3 over 3. Okay, so I'm going to look on my unit circle and see if I can figure out where that happens. First of all, the tangent is negative in these two quadrants. So you would be looking at quadrant 2 and quadrant 4 for a negative valued tangent function. Okay, so just look at where this would go then, and it might help you to to rationalize the denominator on that. That might be necessary. It may not be necessary. But what I'm going to do is I'm going to show you it's either going to be this or this. It's the one that's a square root of 3 in it. Well, let's try this one. We're supposed to get this in radians. So let's see what the tangent of 5 pi over 6 is. If you did the tangent of 5 pi over 6, you would have y over x. So you would have 1/2 all over negative root 3 over 2. 2's would cross out. That would leave you negative 1 over root 3. If you rationalize the denominator, you would get negative root 3 over 3. Okay, so that's what we're looking for. So one of the answers is 5 pi over 6. So without a doubt, that would be one of our answers right there. The other answer would end up being here, because the same thing would happen. Okay, if you did y over x here, the exact same thing would happen. You would get negative 1 over root 3, but that would rationalize to negative root 3 over 3. So you have two answers. Okay, now let me show you something on this one. Okay, when you write the answer, the first answer is 5 pi over 6. So you would say 5 pi over 6 plus the period. Now the period of a tangent is not 2 pi. Do you remember what it is? It's pi. So remember, the period of tangent and cotangent is pi, so you would say pi k, where k is an integer. Okay, that's how that would go. Now, I'm going to show you something on this. I'm going to go ahead and write the next solution. The next solution we would say is 11 pi over 6, again, plus pi k, where k is an integer. But what I want to show you is that second solution is actually unnecessary. Okay, here's why. Okay, if k was equal to 1 in this formula, what you would get is you would get 5 pi over 6 plus pi times 1, of course. Okay, if you got a common denominator on that, so if you multiplied by 6 over 6, notice what you would get is you would get 5 pi over 6 plus 6 pi over 6, so you would get 11 pi over 6 anyway, see? So it's not necessary. So in other words, this formula builds all of the solutions to the tangent. So this one is actually not even necessary. So that would be how you write the answer. It's not wrong to write that second solution. It's just unnecessary. So you don't need to do that on a tangent, and you also don't need to do that on a cotangent. And the reason for this is these are pi apart. And the period of the tangent is pi. So you're going to find that your solutions on a tangent or a cotangent are always pi apart. They're in opposite parts of the unit circle by 180 degrees. So it's not necessary to write that second solution. Okay? So that's how that goes. These problems, of course, could be easily checked on your graphing calculator. But again, what you're trying to do is learn how to write formulas on these. Okay? All right, so I'm going to have you go down here and do the next two. But then I'm going to close off this video because I'm going to do this video in different parts on this. We'll do kind of this part and just kind of break this up into shorter chunks. So go ahead and do the next one. I'll make a copy of this unit circle. So as you're pausing the video and doing this, then you can do that. And please do these problems. When I say pause the videos, that is my intention that you do that, because you're going to learn a lot more from watching me and then you trying to do some problems yourself. You're trying to gain some independence as you're learning this. Okay, go for it. See how. Okay, so here's the solutions you should have got. You may have written your answer a little bit different than the way I did. This is really technically the way you should write your answer. So basically what I did on this is after I isolated, I ended up with, the equation sine x equals negative root 3 over 2. That happens two places. It happens at 5 pi over 4 and 4 pi over 3. So you may have wrote these two answers separately, which is okay, but you can abbreviate this, and technically you should write this as set of x such that x is 4 pi over 3 plus 2 pi k, comma, x is 5 pi over 3 plus 2 pi k, where k is an integer. Okay, and remember, the period is 2 pi, That's why I put that there. Okay, so that's generating all of the solutions as you go more and more laps around the unit circle in both directions. Okay, and that's the idea. Okay, the next one was a tangent. So when you isolated, ultimately you would have got tangent of x equals 1. There's two places where y over x is 1. One of them is here. The other one is here. Okay, so you would get pi over 4 and 5 pi over 4. But you only have to write one of them because the period of a tangent is pi. And if you take pi over 4, the first solution, plus pi, well, then you're already getting to the pi over 4. So you only have to write this one solution. You do not have to write x is 5 pi over 4 plus pi k. That's unnecessary. If you did that, I wouldn't count you wrong probably on an exam or something, but you really should write it that way and just develop the habit of doing that. When you're doing your homework online, it probably will dock you if you write both of those out because it's unnecessary. Okay? All right, so that will wrap up the first part of this video. I'm going to do this in multiple parts because it's a long section with lots of material. All right?